Hello, welcome back everybody. We're on to problem number 30 on this AP Physics C Mechanics multiple choice test. So the problem here is, how does the work required to accelerate a particle from 10 meters per second to 20 meters per second compared to that required to accelerate it from 20 meters per second to 30 meters per second? And our possible answers are A, it is less, B, it is the same, C, it is greater, D, cannot be determined without knowing the force exerted on the particle, and finally E, it cannot be determined without knowing the mass of the particle. Alright, so we're trying to find the work. The useful equation sheet tells us that work W is equal to delta E, the change in the energy of the system, which is also equal to the integral of force dr. So these are the equations that the useful equation sheet gives us to work with. What I'm going to use to solve this is slightly different. I'm pretty sure you can derive it from this, but we're going to use work is equal to a change in kinetic energy. So this is basically this part of the equation. Since the system described here in the problem only deals with kinetic energy, we don't deal with any springs, any gravity. The only things it gives us is basically the velocity of the system, which is proportional to the kinetic energy. We're only dealing with the kinetic energy. So we're saying work is equal to the change in kinetic energy. And if you remember, kinetic energy is 1/2. You can represent this as K, Ke, either one. K equals 1/2 mv squared. M is mass, v is velocity, and we are given some masses here. So basically, we're gonna have this equation twice. We're gonna compare the change in kinetic energy from 10 meters per second to 20 meters per second. We're gonna compare that quantity to the change in kinetic energy from 20 to 30. So let's first solve for the change in kinetic energy from 10 meters per second to 20 meters per second. Alright, so we're going to say work is equal to 1/2 m, and then we're going to subtract, so 20 is going to be our first v, so 20 squared minus 1/2 m 10 squared. That's our change in kinetic energy, our final minus initial. And then we can just factor out the 1/2 m. I'm sorry, I'm running out of space a little bit here. 1/2 m times, we can just, let's do this in one step to save a little bit of space. So 20 squared is going to be 400. And then 10 squared is 100. So that's our first answer. I'm going to leave it in that form just because I'm now out of space. And we're going to compare that to the change in kinetic energy, or the work, to accelerate it from 20 meters per second to 30 meters per second. So this is our quantity for the work. We can simplify this obviously to 1/2 m times 300, and then to 150 m. So that's going to be our final answer for this. 150 m is the work required to accelerate the particle from 10 meters per second to 20 meters per second. So now let's jump into solving the work required to accelerate it from 20 to 30. Work is equal to 1/2 m times 30 squared minus 1/2 m times 20 squared. Let's zoom in right quick so you can see this. Okay. And again, we're going to factor and then simplify, just because I like to factor. So 30 squared, 900. 20 squared, 400. We can see that this work is 1/2 m times 500, which is greater than 1/2 m times 300. So this is greater So the work is greater to accelerate the same particle from 20 meters per second to 30 meters per second than from 10 meters per second to 20 meters per second. So, and it's asking how does the work required to accelerate the particle from 10 to 20 compare to the work required to accelerate it from 20 to 30. So it is less, according to our calculations and this inequality we have. Alright, thank you for watching. Let me know if you have any questions about work, about how I solved this problem, work, acceleration, the velocity here. Thanks for watching, and make sure to check back in for problem number 31. We are almost done. Alright, let me know if you have any comments or questions below.